That's 1/3 x there.
Wasn't the middle,
And, it's that ampersand.
yeah.
Yep. Okay, so what we're going to be doing is working with logarithmic and exponential functions. And the first thing, this book doesn't do a very good job of graphing just exponential functions, so I created 2 problems for you to do it in addition to what we're going to do here. So first, on graphing exponential functions.
I've got it somewhere right now.
Okay. I'm just getting it set up, so you're good. To graph exponential functions, which an exponential function is a function that has a variable in the exponent. So that makes sense, doesn't it? Exponential function. To graph it, all you need to do is pick 0, 2 positive numbers, and 2 negative numbers. And I went ahead and picked -2, -1, and 1 and 2. But you could have picked any 2 positive and any 2 negative numbers and you'd get the graph okay. Does everybody understand what I'm saying there? Okay. Then all you have to do is substitute the number x in for x and find out what y is. So what would be y to the 4 raised to the -2 power?
16.
Not quite 16. Do you guys remember what a negative does when you have it in your exponent? No? It flips it. So 4 squared is 16 and a negative makes it 1/16. Those of you who have your calculators, if you go 4 to the -2 power, you should get a decimal, because 1/16 would be like 0.00 something.
How you do that? I don't remember what.
Okay, go to your calculator
I don't have one.
and get one. 4, and you're going to be using a calculator a lot in this chapter. We're going to have to do logs on our calculators and natural logs on our calculators. So
0.0625.
0.0625. Or we can write it 1/16. Now, does everybody know how to use your calculator and your power key?
Yep.
Okay, so I'll just look here. You put in 4. Your power key's the caret if you've got a reverse polar calculator. Then you put -2 and then hit enter. Is everybody else good there? Okay, yours is a normal calculator. So you go 4, this key, because that's the power key, YX. You put 2 and make it negative, and then you hit equal. Okay, anybody else need help? Got it? Spencer, yours is a different calculator. So you need to go 4. No, yeah, and then you put negative, yeah, you got it. Did you get it? Got it? Do you guys want a calculator to practice it?
I don't know you did.
What?
I don't know you did.
That's because you didn't have a calculator in your hand, so it might be a good idea to get one. Did you need one, Ron?
Yes.
Okay, well, I brought 2 back.
Thank you.
As my aunt says, you're young and simple, which means you guys can move on your feet faster than I can, but you guys have me walking 3 times. Okay, now, this calculator is just a reverse polar. No.
And one in?
Oh, you did 5. 4 to the -2.
Okay, 4. So. Oops.
Yep, that's it. Okay, so again, you could have either done it mentally. 4 squared is 16 and a negative power inverts it, so it becomes 1/16. Or you could have used your calculator and go 4 to the -2 like you just did. Now, what's 4 to the -1? It'd either be 1/4, or if you use your calculator, 0.25. And I'm writing both of them down so you have it. What's 4 to the 0 power?
4.
Everybody should tell me that one, because that's one of your rules of exponents. Anything to the 0 power is 1. Anything to the 0 power is 1. Why is that? We went over that earlier in last chapter. If I have, let's say if I have x squared over x squared, you subtract, but isn't that really saying something divided by itself? Which which is 1. So that's why that works. So anything to the 0 power is going to be 1. Now, what's 4 to the first? Shouldn't need your calculator for it.
4.
What's 4 squared?
16.
Now, we're ready to graph, which you can either use T-graphs or you can use graph paper. Okay, so my first one would be go to the left 2 and up 0.0625. So not very much. Minute amount. Go over to the left 1 and up 0.25, or up a fourth. To 0 up 1, and over 1 up 4, and then over 2 up 16. And that's a graph of an increasing exponential function. As it's getting larger as you work from left to right, does everybody see that? There's some things that you're going to notice about an exponential function, and that is, what do you think about that point right there? Is that going to be part of every exponential function? Is anything to 0 power? Yeah, so every exponential function is going to cross at the point 0, 1, because anything to 0 power is 1. It's also an increasing, right? Has everybody got that one? So now, what if I said y equals 1/4 x? So this is very similar to the example. I'm doing an example, but this is what you're going to do. All I'm doing is changing the bases on the two that you're actually going to do in your homework. Again, to graph an exponential function, you set up a table of values. You pick 2 negatives, a 0, and 2 positives. You always pick 0. You always pick 2 negatives, you always pick 2 positives, just so that way it gives you a good idea of what it looks like. And then you can either use your calculator, or you can do it mentally yourself. So what is 1/4 to the negative 2 power? Now let's think about it. What's 1/4 squared? 1/16, and then what's the negative do? Flip it, so it'd be 16. Or those of you with your calculators, if you go 1/4 caret key, if you got a reverse polar calculator, and -2, it should give you 16, right? Everybody try that. Convince yourself that that works. Okay, what would be 1/4 to the negative 1 power? Well, 1/4 to the first is 1/4, and then the negative inverts it, so that would be 4. What's 1/4 to the 0?
1.
Yeah, always going to be 1. What's 1/4 to the first?
1/4.
1/4. And what's 1/4 squared?
1/16.
1/16. And again, you can use your calculator in the calculator, or go to a decimal and say 0.25 and then say 0. What was it, 625? That's probably enough. Okay, now to graph this, I go to the left 2 and up 16, the left 1 up 4, to 0, 1, which didn't we know that was always going to be a part of this exponential graph? And then over 1 up a fourth, and over 2 up a 16. Then you play connect the dots. Again, where did we cross at?
0, 1.
0, 1. It's always going to cross at that same point. What's different about this graph? It's called, this one's called an increasing one, so what do you think this one's called? Why do you think this one's decreasing? No, I'm saying just look at the base. Look at the bases. This is 4, it's increasing. 1/4, it's decreasing, right? Okay, Robert says it's because it's a fraction. Does anybody agree with that statement?
Because it's less than 1.
Because it's less than 1. Who do you think's right? Let's try. What if I have, don't need to write this one down. What if I have y equals 3/2 x? That's a fraction, right? So let's see if that first scenario works. What's 3/2 to the negative 2? Well, 3/2 squared is 9/4, and that inverts it, right? 4/9. What's 3/2 to the -1? 3/2 to the first is 3/2, the negative inverts it. Anything to the 0 is,
1,
3/2 to the first is,
3,
and 3/2 squared is 9/4. So let's look at this graph. I go over 2 up a little bit, over 1 up 2/3 to 0, 1, that point we're always going to be. Over 1 up 1 1/2, and over 2 up 2 1/4. So what's happening? It's increasing, and that was a fraction. So the key is if the fraction is less than 1, it'll be decreasing. If it's 1 or larger, it's going to be an increasing function. Now, something else about this graph. What else did you notice about the graph? We crossed at 0, 1. We're increasing or we're decreasing.
It never crosses the x-axis.
There's where I wanted here. We're never crossing the x-axis. It's always going to be in the first and second quadrant. Okay, so when you graph these two problems, the first one should look something like this one, right? Because it would be an increasing. The second one should look something like that one because it's decreasing. Also, problem 7 and 1 is graphing. So you're going to get graph 1 there as well. I think it's to the 2 to the x or something like that. Okay, now we're ready for the next part of the assignment. You're going to be solving equations that have variables in the exponents. I'm going to give us an easy one to begin with. And so you don't really need to write this one down. It's too easy to write down. Thank you. See it? Tell by what the answer is by looking at it. Okay, does everybody see that the variable's in the exponent? Okay, so we're solving this type of equation. This is your first experience at doing that. So what do you think the answer is going to be? 2. Why?
5 squared is 25.
Because you know 5 raised to the second is 25. The way that you need to do these is make the bases the same. So that's the key. When the bases are the same, because they aren't always going to be this easy, the second step will be to cancel the bases and solve. And work with the exponents only. Okay, so I'm going to show you with this one.
I can't read that.
Cancel bases and work with exponents only. So in other words, the very first step is the crucial one. You have to write the two bases, which a base, remember, in an exponential is the bottom of the part. That's called the exponent, obviously. What's another way to write 25?
5 squared.
5 squared. So my bases are the same, so I cancel them, and you work with the exponents, and that one I didn't have any work to do because x equals 2. It's already done, which you knew that was the answer. Okay, now here's one you can write down. Now that one's harder to tell what the answer is just by looking at it. Okay, do you guys agree? So I have 3 to the 4x plus 1 equals 9 to the x minus 1. So the key is to do what? No, can't cancel yet. What's the first step? Make the bases the same. So 3 is good. But what's another way of writing 9? 3 squared. So I'm changing 9 to 3 squared. And now, what do you do when you raise a power to another power? Going back over your rules of exponent. Multiply. So that would be 3 to the 2x minus 2. Does everybody concur with that? 2 times that would be 2x minus 2. When you raise the power to another power, you multiply. Now, are my bases the same?
Yes.
I don't see what you just did.
What was it, Nicholas?
I didn't see what you just did.
We made 9 become 3 squared. That's another way of writing it, so the base matches this base. And then when you raise a power to another power, you multiply.
That doesn't make any sense.
When you raise, that's a rule that you've always had. If I have x squared to the third power, what do you do to get your answer?
Well, that's not what
It's the same principle.
that's not what we're doing here.
Yes, it is. When you raise the power to another power, you multiply. That's the same thing you're doing there. You're taking 2 times x minus 1. Now, the bases are the same, so everybody canceled them, right?
Yep.
So we've got 4x plus 1 equals 2x minus 2. What would we do to solve it? So once you get the bases to be the same, you cancel them, then the solving is just like normal. It's nothing new. Then what? Subtract 1. So x equals -3/2. Okay, and just for this one, I'm going to show you that it really does work. Okay, you don't need to write this down. If I put a -3/2 in here, this would be 3 to the 4 times a -3/2 plus 1 equals 9 to the -3/2 minus 1, right? Isn't the rule that if you want to check them, don't you put it back into your equation in place of x? Okay, so what's 4 times the -3/2? That'd be -6, right? Plus 1 is, okay? We're going to use your calculators here in a minute to double check things. What's a -3/2 minus 1? -5/2, right? Okay, so this half of the room, you find out what 3 to the -5 is. That half, you find out what 9 is to the -5/2 power. It should be a decimal.
Am I supposed to be how many zeros?
You're going to have a few zeros.
Yeah.
What did you guys get?
0.004.
0.004s? Okay, what did you guys get?
The same.
The same thing? I hope it's the same thing. Because that would prove then it did work. Do you guys follow what we did there? Okay. Well, let's do another one. Now, after you get about a few of these written down, you don't need to write down anymore, but I'm going to give you plenty to practice. What's the very first step you have to worry about?
Base is the same.
You gotta make the bases have to be the same. So what's another way of writing 25?
25. Or 5 squared.
5 squared. You gotta raise it to a power, basically. What about 125? 5 cubes. Does everybody agree 5 times 5 times 5 is 125? So it's 5 to the third. Then what do you do when you raise a power to another power? Multiply. So that rule has never, we've used it for a long time now.
Can't we just cancel those things out?
That's what we're gonna do. But I first get rid of raising, do you leave parentheses in your problems when you're solving? Nope. So what do we get here? 6x. Now, we're gonna cancel our bases.
Yes.
Yes. What would we do to solve it?
Subtract 2x.
So once you get your bases canceled, then it's simple solve. So subtract 2x.
X equals 1.
And this one would be easy to check, wouldn't it?
Mm-hmm.
This side do, what's 125 to the second power? And this side over there do 25 to the 1 plus 2, so 25 to the third power? What you guys get? 15625.
Same.
Same, so we know our answer's right. So you can always substitute it in and double check to make sure it works. So everybody follow that if you want to check. Now I'm going to give you one that's looks a little different. Let's go. 36 as?
6 squared.
6 squared.
216, 6 cubed.
216 is 6 cubed, right?
Mm-hmm.
But I need to have it up on top, right?
6 is negative
So you make it 6 to the negative third power. I just did an extra step. You don't really need to do that extra step. I did that just to emphasize the fact that when it's on the bottom, to move it to the top, you make it a negative power. Now, what do you do when you raise a power to another power?
Multiply.
Bases are now the same. So it's 2x plus 4 equal to a negative 3. What would we do to solve it? Subtract 4.
I got -1 now.
I got negative 7 here.
Oh, I did, I heard you.
I bet your 3 wasn't negative when you did it. And then again, of course, you could check it, right? To double check that it's right.
Yeah.
Did you agree then, Robert?
Yeah.
Okay, I'd say you're probably good, but I'm gonna do a few extra. And this one's gonna be looking a little bit different.
Do you want us to still write these?
No, no. Unless you just think you need an extra one. I'm writing it a little, it's a little different, but I think you can figure it out. So we need same bases, don't we?
Mm-hmm.
What's 49 gonna change to?
7 squared.
7 squared. And I'm gonna put this for emphasis only. You normally don't have to put that 1 there, right? Okay, it's understood to be a 1 if nothing's there. What about 343? 7 cubed. So this is 7 to the 2x plus 4 times 7 to the first equals 7 to the 3x minus 3. You raise to a power, you multiply, raise to a power, you multiply. Now, what do I do over here? I want just one base, and I've got 2.
Multiply.
When you multiply, what are you supposed to do with your exponents? See, it goes back to our rules of exponents. Rules of exponents come back to haunt you still again. So what's 2x plus 4 plus 1?
2x plus 5.
Is it okay if I just go ahead and say plus 5? Or you could have written it the step 2x plus 4 plus 1 in there. Now are my bases exactly the same? So 2x plus 5 equals 3x minus 3. What would we do to solve?
Check for 2x.
Add 3 and x equals 8. And this one would be another one that'd be easy to check. 8 minus 1, 7. 343 to the 7 I know is a huge number. And over here, we have 8 plus 49 to the 10th. Whatever that answer is times 7. Yeah, it'd be a big number. It'd be overflow error maybe in your calculators. Okay, so this whole section, 45 through 56 is solving. Every one of the problems is solving exponential functions where your variable's in the exponent. Then what's the step you have to do? What's the very first step? Bases have to be the same. What's the second step? Cancel the bases and then work with the exponents only. And then graph, you might want to start with your graphs first so you don't forget it. I want graph y equals 3 to the x and graph y equals 1/3 to the x using your table of values and graphing. And 71 is also an additional graphing problem. Okay, do you guys have questions? And I know 71 asked you to describe and compare. You don't have to. All I want it done is graph. We've already kind of described and compared, didn't we? Didn't we say it was in the first and second quadrant? It crosses at 0, 1. Okay. So I would like to see your 2 graphs here and then 45 to make sure you're on the right track. Okay, somebody want to get the... And then Aaron, do you want to start test here or do you want to just save it for seminar?
I'll just save it for seminar.
Okay.